Have you ever wondered what happens when the sky simply refuses to change its mind? Right this second, sitting quietly and menacingly over North America, there is an atmospheric trap so rigid and unyielding that meteorologists are watching it with a deep, quiet sense of unease. Before we unpack how this invisible monster is about to alter life for millions east of the Mississippi, take a quick second to hit that like button, subscribe to the channel, and share this video with someone you care about who lives in the path of these storms. Now, imagine looking up at a sky that looks deceptively calm, blue, and ordinary, while thousands of feet above your head, a massive planetary gear system has jammed. It is not just a heat wave in one city and a rainstorm in another that happened to cross paths on the evening news. This is a single, unified, monstrous weather architecture locked into place, and it refuses to budge for the next 10 agonizing days. When you look at the forecasting maps right now, you're not seeing random chaos. You're looking at 4 entirely different, terrifying hazards being fed by one single mechanical beast in the upper atmosphere. There's a suffocating heat dome baking the upper Midwest and triggering toxic air quality alerts that reach all the way into the Northeast. There's a relentless conveyor belt of severe thunderstorms stretching from Montana down to New Jersey, primed to unleash destructive straight-line winds. There's a historic, unforgiving flash flood emergency drowning parts of Texas in wall after wall of rushing water. And quietly, almost invisibly, a tropical disturbance is organizing itself in the warm bathwaters of the Gulf of Mexico on the exact historical date the Atlantic traditionally births its second-named storm of the year. 4 massive hazards, all born from one single root cause. If you live anywhere east of the Mississippi River, your entire life, your commute, your weekend plans, and your safety over the next 10 days depend entirely on which side of this colossal atmospheric fracture you happen to be standing on. To understand why forecasters are choosing their words with such careful, nervous precision, we have to look past the surface and examine the invisible architecture ruling our skies. High above the clouds, 30 to 40,000 feet up in the freezing expanse of the upper troposphere, the jet stream usually acts as a reliable, fast-moving river of air, cleanly separating the bitter cold of the north from the gentle warmth of the south. In a normal, peaceful middle of July, that boundary rests comfortably far to the north, allowing the eastern half of the United States to settle into a predictable rhythm of summer. You get hot, humid afternoons, followed occasionally by a brief, dramatic, but ultimately harmless pop-up thunderstorm that cools the pavement and disappears by dinner time. But this week, that familiar rhythm has been completely shattered. What has replaced it is a brutal, unyielding east-west split that has turned the atmosphere into a pressurized machine. A massive ridge of high pressure, functioning essentially as a gigantic dome of sinking, superheated air, has planted its heavy boots right over the northern plains and the upper Midwest. It is parked there with such staggering persistence that weather prediction centers are running out of adjectives to describe the anomalous, suffocating heat it is radiating eastward into the northern mid-Atlantic. On the exact opposite side of that very same atmospheric coin, the jet stream is being violently contorted into a sharp southward dip known as a trough. This trough is acting like a giant vacuum cleaner, dragging cold, hyper-energetic disturbances out of the heart of Canada and flinging them southeastward directly into the thick, moisture-laden air sitting over the eastern United States. These two seemingly opposite features, the baking ridge in the west and the plunging trough in the east, are not two independent weather anomalies that just happen to show up at the same party. They are two ends of the exact same planetary wave. The high-pressure ridge is the engine, and its eastern flank acts like a relentless conveyor belt. That conveyor belt catches every single disturbance sliding down from Canada and fires it directly into the heavy instability lingering over the Great Lakes, the Mid-Atlantic, and the Northeast. Without that ridge holding its ground in the north-central states, this endless conveyor belt of storms wouldn't exist. And without that conveyor belt, we wouldn't see organized severe weather lining up day after day along the heavily populated Interstate 95 corridor. It is a single, interconnected machine, and understanding it changes everything about how you prepare for what is coming. The first terrifying manifestation riding this atmospheric conveyor belt is heat, but this is no longer just a localized problem for the northern plains. The heat is migrating, spreading its suffocating fingers into the northern mid-Atlantic, dragging thick, stagnant air along with it. This is why air quality alerts are currently stretching from the upper Midwest through the Great Lakes and all the way into the Northeast, blanketing millions of people in invisible haze. That detail, the drop in air quality, is something you ignore at your own peril. And when a massive high-pressure ridge parks itself over a region, it does 2 dangerous things simultaneously. It traps heat directly at the surface, turning cities into ovens, and it acts like a lid on a pot, trapping microscopic pollution, exhaust, and ozone right down at breathing level. That is why a severe heat dome and a choking air quality alert almost always show up on the exact same forecast maps. For anyone living within that corridor, the practical reality demands immediate adjustment. You have to limit strenuous outdoor physical activity during the brutal peak afternoon hours, check in on elderly neighbors who might not have functioning air conditioning, and treat an air quality alert with the exact same gravity you would give a severe weather warning. For individuals battling asthma, chronic bronchitis, or underlying heart conditions, breathing stagnant, polluted air during a prolonged heat wave doesn't just make you uncomfortable. It compounds the physiological stress on your body in ways that can quickly become life-threatening. But the heat is only the prologue to a much larger, more violent sequence of events unfolding across the country. The second major hazard is the one directly powered by that atmospheric conveyor belt, and it is not arriving as a single, clean storm system. It is rolling in relentless, overlapping waves. Across the northern edge of the high-pressure ridge, strong. 2 severe thunderstorms are already hammering parts of western Montana. Meanwhile, entirely separate clusters of severe storms are battering northern New England, the very same region that has taken an absolute beating from repeated storm systems throughout this entire season. But the truly consequential piece of this puzzle, the one keeping meteorologists awake at night as they watch the computer models update, is sitting farther south and east. Specialized severe weather desks have flagged an elevated, highly dangerous risk of thunderstorms stretching all the way from Florida up through New Jersey, locking a bullseye directly onto the densely populated coastal corridor surrounding New York City. The primary threat here is not necessarily an isolated, dramatic tornado touchdown, though those cannot be entirely ruled out. The primary widespread hazard is a barrage of violent, damaging straight-line wind gusts capable of carving paths of destruction across entire counties. That distinction between rotating tornadoes and straight-line winds is crucial to understand, because it fundamentally changes what you need to prepare for. These are not the classic textbook supercell thunderstorms that form isolated spinning funnels tracking along a narrow, predictable path. What is forming here are massive mesoscale convective systems, gargantuan clusters of thunderstorms that organize themselves into a solid, towering line known as a bow echo. This entire wall of fury races forward as a single, unified unit, shoving an aggressive wall of hurricane-force wind out ahead of the actual rain. That kind of system does not need to touch down as a tornado to wreck your neighborhood. A well-organized line pushing relentless gusts of 60 to 70 miles per hour across a broad, unbroken front can snap mature hardwood trees, obliterate power lines, and rip roofs off buildings across an entire region in the span of just a few terrifying minutes. Because these systems move with terrifying speed and cover ground rapidly, the official warning time issued to any single community can be drastically shorter than what people have come to expect from ordinary summer afternoon thunderstorms. This is the exact moment where honest meteorological uncertainty enters the conversation, because true forecasting isn't about pretending to know the future with absolute perfection. It is about clearly communicating what is still up in the air. When we look at extended computer model ensembles, there's a clear consensus on the broad strokes of this western ridge and eastern trough setup. However, there is still meaningful disagreement among forecasters regarding how much wind shear will ultimately be available to organize these storms into truly widespread, catastrophic, straight-line wind damage versus more scattered, isolated downbursts. In some of the model guidance, weaker vertical wind shear could potentially limit how cohesive the wind threat becomes on any specific afternoon. Even so, the foundational thermodynamic ingredients, the intense heat, the suffocating humidity, and the raw atmospheric instability fueling these storms, are locked in with absolute certainty. In plain, honest language, forecasters are completely certain that the atmosphere across the mid-Atlantic and the Northeast will be aggressively primed for strong to severe thunderstorms throughout the weekend and into next week. What they are still refining, day by day and run by run, is the precise footprint of where the worst of the damage will strike. That is why looking at a static forecast a week in advance is a trap, and why official outlooks are constantly being updated. If you live anywhere within that sprawling corridor from Florida to New Jersey, the most intelligent thing you can do is treat any severe thunderstorm warning issued this weekend as an immediate, serious threat to life and property. Before we dive into the catastrophic flooding currently unfolding and what is brewing in the Gulf, let's pause right here. Drop a comment down below letting me know what state you are watching from and whether you've noticed the weather acting strangely in your area this week. And make sure you share this video with your family members living along the East Coast so they aren't caught off guard. Now, let's look at the third major hazard in this multi-threat event. A hazard that doesn't need the jet stream's conveyor belt to reload because it is already actively unfolding with devastating consequences. Unlike the heat and the wind, which are sweeping across broad regions, this threat is concentrated, stationary, and brutally stubborn. Forecasters have repeatedly flagged excessive, catastrophic rainfall totals across the Texas Hill Country, with the focus steadily shifting toward the Big Bend region, as a massive, stalled frontal boundary continues to drape itself across the southern tier of the country. That single detail, a stalled frontal boundary, is the key to understanding the most. Lethal type of flash flooding known to meteorology. When a weather boundary simply refuses to move, it acts like a conveyor belt of a different kind, producing training thunderstorms. These are storms that form repeatedly over the exact same patch of saturated ground, one right after another, much like railroad cars running over the same stretch of track, instead of distributing their heavy rainfall across a wide area. In rugged terrain like the Texas Hill Country, where steep, narrow canyons and hard limestone act like natural funnels, this kind of relentless, concentrated rainfall turns a dry creek bed into a roaring, lethal wall of water in a matter of minutes. At the exact same time, deep monsoonal moisture is surging northward, generating severe flash flood risks across the interior Southwest, with the greatest concern focused tightly near the southern borders of Arizona and New Mexico. This is a stark reminder that this weather pattern's destructive potential is not confined to a single river basin or a single state. Flash flooding remains consistently one of the most misunderstood and underappreciated hazards in any complex weather event, and the psychological reasons behind this are deeply ingrained in human nature. Tornadoes and straight-line winds are loud, visible, dramatic, and incredibly easy to visualize from a warning alone. Flash flooding, on the other hand, is deceptively quiet, often difficult to visualize in the abstract, and frequently provides far less lead time than people mistakenly assume. A stretch of familiar suburban road that looks like a shallow, manageable puddle can actually be hiding rushing water, moving at a velocity strong enough to lift a 2-ton vehicle off the pavement and sweep it away before the driver even realizes what is happening. The golden rule preached by emergency managers for generations remains heartbreakingly relevant every single time this happens. Turn around, don't drown. No flooded roadway, no matter how familiar your commute is or how short the detour might seem, is ever worth the gamble. But while the heat, the wind, and the floods are dominating the headlines, there's a fourth hazard currently cooking in the background, one that is still actively working out its true intentions in real time, sitting quietly in the warm waters of the Gulf of Mexico. The National Hurricane Center has been closely tracking a sprawling area of disturbed weather in the northeastern Gulf, granting it a low but deeply significant chance of organizing into a tropical depression or tropical storm over the next 7 days. While the development odds hover around 20% in the short term and sit near zero for the immediate 48-hour window, seasoned meteorologists know better than to dismiss a system simply because its initial odds look modest. If this disturbance does manage to organize and pull itself together, the next name waiting on this year's Atlantic storm list is Bertha, followed closely by Christabel. There's a fascinating, almost poetic detail here that is very easy to overlook. The historical average calendar date for the Atlantic hurricane season to produce its second named storm is July the 17th, which happens to be right now. That calendar coincidence does not automatically guarantee that this specific atmospheric disturbance will explode into a major storm, but it does mean the timing aligns with ruthless precision against the backdrop of a normal Atlantic season. This is happening even in a year where seasonal forecasters expect the overall basin to run somewhat below historical averages, largely due to a strengthening El Niño pattern working hard to suppress widespread tropical development. But here is where the average statistics completely fail to capture reality. A below-average season for the entire Atlantic basin does not mean a quiet season for any individual coastal community, and it certainly doesn't mean individual systems can't pack a devastating punch. The honest, unfiltered characterization of this developing Gulf system right now is that of a rising possibility rather than a settled outcome. Major university hurricane research groups recently trimmed their full-year forecasts downward precisely because of that El Niño influence, and official government outlooks sit in a similarly modest range. Yet, the Atlantic basin being quiet overall is entirely irrelevant if a homegrown system decides to park itself right off your specific stretch of coastline. Gulf origin disturbances that form close to the shore carry their own unique, terrifying danger, completely independent of how strong they ultimately become on the Saffir-Simpson scale. Because they develop right on the doorstep of the landmass, they compress the amount of lead time coastal communities have to prepare, taking away precious hours that residents in places like Florida, Alabama, Mississippi, and Louisiana rely on. And because they tend to form inside a stalled, sluggish, large-scale weather pattern rather than racing across the open ocean, these homegrown systems tend to drift lazily rather than march forward with speed. That means whatever torrential rain they carry gets trapped, giving the storm more time to sit, spin, and continuously dump catastrophic accumulations over the exact same stretch of coastline day after day. That exact mechanism is why forecasters are already flashing warning lights over the Florida Panhandle and the surrounding southeast, highlighting those regions as facing the greatest cumulative rainfall risk from this system. Whether the National Hurricane Center eventually upgrades this cluster of thunderstorms to a formally named storm is almost secondary to the immediate threat. A slow-moving, disorganized area of low pressure lingering over Gulf waters that are currently running significantly warmer than the historical mid-July average is going to squeeze out monumental, life-threatening rainfall. Totals, regardless of what technical label is stamped on it. The absolute smartest way to track which direction this evolving situation is heading is to keep a close eye on the official tropical weather updates released twice daily. If those development percentages begin to climb in subsequent advisories, or if the system gets upgraded from an anonymous area of interest into a tracked invest, that numerical shift is your definitive signal that the odds have officially crossed the line from a background possibility into an active, urgent coastal threat. It is vital to understand why veteran meteorologists keep circling back to that seemingly low 20% chance instead of writing it off completely. In the complex mathematics of the atmosphere, a low chance is never the same thing as zero chance, and the underlying ingredients sitting beneath that modest percentage are the exact building blocks forecasters look for when a weak, disorganized system is poised to explode. Look at the data. Water temperatures across the northern and eastern Gulf of Mexico are running notably warmer than the historical mid-July average. And in NOAA, the physics of weather, warm ocean water is the ultimate high-octane fuel supply for any tropical system. Full stop. At the same time, wind shear, that destructive difference in wind speed and direction between the surface and the upper atmosphere that normally acts like a buzzsaw tearing developing storms apart before they can organize, is forecast to relax significantly across the northeastern Gulf as we head into the weekend and early next week. Take exceptionally warm water, declining upper-level wind shear, and a stalled frontal boundary providing a gravitational anchor for low pressure to gather around, and you have the textbook recipe for a homegrown Gulf storm. These systems don't spend weeks traversing thousands of miles of open water like a classic Cabo Verde hurricane born off the coast of Africa. They can spin up from a disorganized cluster of heavy showers into a menacing tropical depression in less than 48 hours. That lack of warning time is precisely why monitoring the situation day by day is not optional for anyone living along the Gulf Coast. Before we reveal the final synthesis of this 10-day weather event and look at how every single piece connects into a master puzzle, let's take another brief moment. Share this video with a friend or family member who lives near the water, and make sure you're subscribed so you don't miss our crucial daily updates as these storm tracks shift. It also helps to hold two seemingly contradictory ideas in your mind at the exact same time without letting one cancel out the other. The first idea is that the broader seasonal outlook for tropical activity is leaning below average due to the overarching presence of El Nino, which generally injects hostile wind shear across the wider Atlantic basin. The second idea is that a macro-level seasonal forecast is completely useless when a slow-moving, localized homegrown system plants itself directly over your backyard for 48 hours and dumps 2 feet of rain. The seasonal average describes the collective behavior of an entire ocean basin over 6 months. It does not describe your personal reality if a stalled system floods your neighborhood. Step back now from the individual pieces and look at the entire 10-day picture as a single, magnificent, terrifying work of atmospheric art. Because that is the true takeaway here. The massive ridge of high pressure parked over the northern plains is not a separate, unrelated weather event from the severe storm threat racing across the mid-Atlantic. It is the literal reason that storm threat exists in the first place, because the eastern edge of that ridge acts as the high-speed conveyor belt feeding disturbance after disturbance into the unstable air sitting over the east coast. The stalled frontal boundary, draped across the southern tier, ringing out endless rounds of flash flood-level rainfall over Texas, is anchored to the southern extent of this very same planetary wave. And the gathering moisture in the Gulf of Mexico is responding to the exact same large-scale pressure adjustments, heat in the north-central states, severe straight-line wind threats tearing through the mid-Atlantic and northeast, catastrophic flash flooding drowning parts of Texas and the interior southwest, and a creeping tropical concern in the Gulf, are not 4 different stories. They are 4 different symptoms of one massive, unified atmospheric setup. And that setup is not scheduled to break down, weaken, or reorganize into something calmer for the better part of the next week and a half. Here's how you actually practicalize this information. If you find yourself living inside the crosshairs of this pattern, if you're sitting in the upper Midwest, the Great Lakes, or the northern mid-Atlantic, the oppressive heat and the accompanying air quality alerts are the parts of this pattern that demand steady, disciplined responses rather than frantic panic. Hydrate continuously, ruthlessly limit your outdoor exertion during the brutal afternoon peak hours, and take the air quality warnings seriously if you or anyone in your household battles respiratory or cardiac issues. That alert is not bureaucratic window dressing. It is a second invisible hazard riding shotgun alongside the heat. If you are located anywhere from Florida straight up through New Jersey, encompassing the densely packed coastal corridor surrounding New York City, this weekend is your critical window to pay absolute attention. The atmospheric ingredients for organized, destructive straight-line wind events are already assembled on the shelf, even if the precise day-to-day placement of the worst damage is still being fine-tuned by forecasters running the latest computer models. Treat any severe thunderstorm warning issued for your county this weekend as a genuine, immediate threat to trees, power lines, and anything not bolted down outside, rather than dismissing it as routine summer noise. If you are in Texas, particularly the Hill, country, the Big Bend region, or anywhere along the southern tier sitting adjacent to that stalled frontal boundary, the flash flood threat is not a distant possibility on the horizon. It is an active, ongoing emergency. Never, under any circumstances, attempt to drive a vehicle through water covering a roadway, no matter how confident you feel about the depth or how many times you've driven that route before. And if you reside anywhere along the Gulf Coast from Louisiana eastward through Florida and up into the Carolinas, the upcoming national hurricane, center updates, refreshing twice daily, are your single most reliable compass to determine whether this developing situation is accelerating into a genuine coastal crisis or simply dissolving back into ordinary seasonal heavy rain. None of these four threads exist in isolation from one another, and none of them have finished writing their final chapters. The exact geographical placement of the weekend severe weather will continue to sharpen as the ensemble computer guidance converges. The development odds for the Gulf disturbance could swing meaningfully in either direction over the next few forecast cycles as the ocean and the atmosphere negotiate their terms. The duration of the flash flood threat across Texas hangs entirely on how stubbornly that frontal boundary refuses to budge. And the precise eastern extent of the heat dome over the coming days will dictate just how far into the mid-Atlantic those choking air quality alerts ultimately reach. Every single one of these unfolding questions deserves rigorous, clear-eyed tracking as the weather pattern evolves, verifies, and shifts in real time. That is precisely what this channel will be watching, analyzing, and breaking down for you day by day. Subscribe right now and turn on all notifications so you see the critical updates the moment official outlooks change, rather than finding out after the damage is already done. One locked, unyielding atmospheric pattern, 4 powerful hazards riding the exact same mechanical structure, and 10 days that will test the resilience of millions. The sky has made its move, and how we respond over the next week and a half will write the conclusion to this remarkable chapter of summer weather history.